Okay, awesome. Looks like a lot of people are joining, so I guess we could get started. Hello, everybody, and welcome to the Doroni Aerospace webinar. This is a special roundtable discussion with our credible team of engineers. My name is Abe Datz. I'm head of marketing and investor relations here at Doroni. I'll be your host for today's session, and I'm thrilled to have you with us. I've had the pleasure working closely with these talented engineers over the past 2.5 years, during which we faced challenges and celebrated successes together. I'd also like to take a moment and thank all of you investors that are joining right now. I got to know many of you personally, and we really appreciate your unwavering belief in the future of technology and the support of our mission. You guys are simply amazing. Today, we're just 5 days away from closing our campaign on StartEngine, where we've raised combined over $7 million over the past 2 years. Before we discuss what's next, I'm excited to dive into deep conversation with engineers. We'll be talking about what we've been working on, the innovations behind the H1X, and the challenges that we've overcome. Along the way, we'll get to hear firsthand about their passion for revolutionizing transportation and the future steps for Doroni. Our engineers are the backbone of what makes Doroni stand out. With our cutting-edge design, relentless innovation, we pride ourselves with having a team that thinks differently, creating products that's not only groundbreaking, but also designed beautifully. As we go through today's discussion, please feel free to submit your questions below. We'll do our best to answer as many as possible. And remember, if you don't get your question during the webinar, you can always schedule a one-on-one meeting. I'm going to leave in the chat soon my calendar, and I'll be happy to address anything further. Now let the engineers introduce themselves. Let's start with Derek.
Hello, everyone. I've been with Doroni. I'm the chief electrical and electronics engineer here at Doroni. I've been here with Doroni for 8 years now, since the very beginning. So my background before that, I've been engineering racing battery packs for about 23 years, starting with custom lead acid cells, moving on to lithium cells as they became popular. And they were produced. There was a lot of them that weren't even produced before then. Right now, so during that racing period, I was able to do many things. Had first vehicles to go over 200 miles an hour in a quarter of a mile. Had motorcycle, car, and then I had a Formula One car that did circle track over 200 miles an hour. I've worked with many different companies, GM, Harley Davidson, a lot of aerospace as well. Did their battery for them on their first battery prototype. Worked on many different TV shows as well, and then we've been seen on many news channels as well as Fox. Laura Ingram is one of them, but there's many other things as well. So just want to let you know exactly what was going on. With the Doroni Aerospace, we'll be talking about it today.
Awesome, Derek. Thank you so much. It's been a pleasure working with you. I've learned a lot from you over the past 2.5 years. So now let's go to our next engineer, to Zar, tuning in from the UK.
Hi guys, my name is Zar. I'm the Chief Systems and Software Engineer for Doroni Aerospace. So I've been with Doroni similar time as Derek. So I was one of the very first engineers that worked on this in Doroni's garage. Still remember the first days. So my background is I started as an electronics engineer, and then I kind of sort of transitioned to software. So I worked with various startups, mainly doing embedded things, and then moved to consulting, and then moved to Doroni full time. Was it 2 years ago, 2021? So yeah, that's me.
Okay, awesome, Zar. There's a lot more to you that we're definitely going to go into a deep discussion.
Yes.
Next up is Ido Shabi.
Hey guys, pleasure to meet you all. So I'm already 2 years in Doroni, mainly doing software engineering. In my past, I worked in various companies regarding software development and different aspects of cybersecurity as well. So many products that help to prevent detection and prevent any attacks or stuff like that. So mainly everything related to that. So I learned a lot of how to develop software correctly and securely, which is those aspects we've been integrating into the Doroni. Yeah, and excited to be here today and with you guys.
Awesome. I'm excited to have the discussion with you as well. So our next up is Alistair, also tuning in from the UK. Let us know who you are.
Cool. Hi, everyone. So yeah, I'm Alistair. I'm based in the UK. I've got a lot of experience. So one of my first jobs after university, which was Cranford University, which is the UK's leading university for aerospace stuff. It's the only university which has an airstrip on site, and some of your lectures are done from the air, which is quite cool. Worked designing components for Airbus was one of my first jobs before moving on to being one of the main designers for eco airplanes, which is similar to Doroni, really. It's a sexy carbon fiber aircraft, and it's got a lot of parallels with Doroni. We achieved a lot without much funding, and we sort of got the aircraft to a flying prototype model and then moved it into production. So it's very similar to where we are currently with Doroni and where we're going with Doroni. I've done a lot more work since then, a lot of it in the aerospace and defense sector, which has led me to Doroni, where I'm the lead mechanical and aerospace guy. So you'll hear more from me later.
Yeah, awesome, Alistair. You definitely brought a lot to the table since you joined, and we're excited to get into this discussion. And last but not least, we have here Charles Bond, our test pilot. He has the most fun of all of us. He gets to fly the Doroni, so let us know who you are.
Hey, morning, everybody. Afternoon, wherever you're from. Thanks for joining us. Again, as Abe said, thank you. I'm Charles. I'm the test pilot for the company. I've been involved with Doroni for about 6 years now. It's amazing how time flies. I've been a jet captain for the past 20 years. Been involved in aviation for the past 25 years, doing all sorts of exciting things over time. But Doroni is definitely the most exciting that I've been involved with, and no regrets for being here and what we're doing.
Awesome. Okay. So thank you all for this wonderful introductions. Before we dive into our deep discussion, I would like to take a moment to reflect on the credible work you team have accomplished over the past few years. I also want to share how far we've come utilizing the $7 million we've raised and how we're now strategically positioned to enter the next phase of development that will truly elevate Doroni to new heights. Our journey has begun when our founder, along with some of the engineers that you've heard from today, Derek and Zar, had envisioned building a flying car. This concept was sparked by the advancements in drone, electric vehicles, and battery technology. What has started as a one-seated prototype, as you guys can see over here, in a living room and a garage, quickly evolved despite the challenges of limited components available for the project of this scale. We knew we had something special. Our efforts were even validated when we won an aerospace competition in Florida, but at that time, it was still very early, and it was still a garage project. That was in 2018, 2019. Then COVID came, which put progress on hold. Meanwhile, what happened at the same time, billions of dollars have been invested into electric vehicles and eVTOL air taxis, which dramatically advanced the technology we needed to develop a personal flying car. So we upgraded the design in 2021. We updated the design from a one-seater to a two-seater, and that's where the H1 was born. With the new design in hand, we launched the first fundraising on StartEngine. We raised $1 million. That funding allowed us to build a full-scale simulator, which we showcased at Oshkosh Air shows where tens of thousands of people were able to fly a simulator. We were gaining partnerships and boost a tremendous visibility in our industry and creating our name for ourselves. As additional funding came in, we moved out from the garage into a dedicated facility in Miami, where we began building the full-scale H1 prototype. Despite various sourcing challenges, we preserved and designing our own batteries and other key components. As we approached the assembly phase of the electronic components and starting test flights, it became clear that we needed more space, because from the garage we moved into a smaller facility. So we needed to move into a larger 10,000 square foot facility in Pompano Beach, where we conducted full range test flights, from tethered flights. We did software integration and motor testing, and that's where we had our CEO takeoff. And additionally, at that time, we were also able to receive FAA Special Airworthiness certification for our prototype. The data we gathered since revealing the data we gathered from testing was invaluable. It led to redefine the H1 design into the creation of the H1X, and even more efficient, aerodynamic, and innovative aircraft that we believe will meet our mission and our goal that we really want to give to our customers. We also filed 9 patents, with 2 critical ones granted for our ducted design patent, for our ducted design, a key technology feature for eVTOL in the long term, as we believe that ducted technology is really important in order to bring a vehicle like this to life. And as well, we also received over 500 pre-orders. In the past 8 months since we've revealed the H1X, our team has been laser focused on every detail and requirements needed, as we'll need to continue the development and work with the FAA to get certification. This includes building state-of-the-art test fixture to further optimize our components that we have. I don't know if you guys have seen, but we've released a couple of videos of how we're doing intense testing with all the new components. In the meantime, we've also been working tirelessly to secure the larger funds needed to bring the H1X to market, where we're now at the verge of closing a significant deal. Whoever's been on StartEngine has been able to see that we're working on a $30 million deal from a Saudi company. Disclaimer, this is still in the early stages, but we're really close, and we believe that we will get the funding needed to go into the next step so we can bring the H1X to market. So now where we are, we're 5 days before the campaign. Let's dive into the conversation, and let's start with Derek and Zar. Both of you, you guys have been here from the beginning. What was it like when you started? There was nothing really available at that time. No one was really building anything, but you had a big vision, and you guys are passionate. And as you guys have shared for your backgrounds, you've always been playing with different things. But you had so little to work with. How did you manage to bring the initial idea to life, the first 3 prototype? And how in the world did you build 2 prototypes in the garage? So Derek, if you could start sharing, how we started and how we got to the two-seater design.
Sure. Well, it all started when Doroni contacted me via email. He said he wanted to build a flying car, and I'm like, yeah, it's about time. I was ready for it myself. I've been watching all these movies and waiting and so forth. And, we were thinking, if like I've always tried to be first at doing things. So, first, I worked with a lot of companies when they first started up, trying to help them get going. So I always like to be first at things, if possible. Nobody remembers second. So when he called, I'm like, yeah, let's build that. Let's build it. Let's put it together. Let's make it happen. So I started designing the battery. We had a couple other engineers. They're not with us right now, but they were at the beginning, Roman and Oleg. They were involved with the first mechanical design. Czar was working on the software side, and I was designing the electronics for it. So I hand built a lot of electronics. Czar programmed those. So he can talk about that as well. But yeah, it was a big adventure. We started out with a three duct design, a Y configuration,
Yeah, as you
not
can
an
see,
H configuration.
Yeah.
Yeah, you can see it there in the picture in the middle and the person, the video. You can see us testing it as well. We were actually building it inside the house in the living room. So that was kind of crazy. I mean, we were doing motor tests and stuff inside the house, create a lot of wind. Then we took it outside, of course, and flew it as best we could. Then we decided that, you know, this wasn't producing enough lift on the rear fan. We had a little bit of drag. From that, we were just not enough power coming out that size of a duct. It would have to be enlarged quite a bit to work. So we went to a H configuration, and that was much more stable, much better design. I don't know, Czar, you want to talk about anything?
Yeah, I mean, the first prototype was, as you can see there, it's like a seated drone, no covers whatsoever. But yeah, it certainly was an exciting first few years. And then yeah, I was doing the programming. Doroni flew me over from the UK. I stayed there for a good few weeks in his house trying to build this thing for the first flight. Yeah, it was good. I mean, it was what, early 2016, 17. Wasn't it, Derek?
Yeah, he contacted me in 2016, and you and I started talking. I just looked at some old emails. Somewhere around March of 2017, we started putting it all together, heads what we were going to build. So we were moving really fast, actually. I mean, we had this thing up and running really quickly after that.
Yeah, it was.
That's actually incredible because, like in that early stages, you guys just jumped into it, and you know, I don't think the company was really formed. It was just like a few engineers with the big vision, and you just, you know, weren't asking a million questions. Just you will see, okay, let's do this. Let's see how we can get it done. We know there's a lot of challenges, we know, but you know, you got to start somewhere. You got to start doing it, and that's really amazing. It's crazy to think of, you know, and that's why I admire you guys so much. So if I can ask, so we started with you said the Y configuration, then the X. If you can share a little bit the transition from the one-seater and when we started the company really in end of 2021, when we started the fundraising where we redesigned it into a two-seater, what was the thought of like, why were you guys going with a specific design? And can you give us just a little overview of what went behind what was the decision behind that?
Yeah, flying on that one-seater version is kind of a little scary. It's it's open, you know, it's still very comfortable and everything, but it was more of we felt it wasn't adequate enough. I mean, if you got a family or anything, two people, you could only fly, you'd have to buy two of these to fly anywhere. Yeah, it was kind of a fun toy, but it just didn't feel like we were changing the world, you know, at that moment. So there was a lot of different issues with it. I mean, we felt that the two-seater was just the way to go. I mean, it made sense to build a small vehicle, car-like structure around it. You feel a lot more secure.
Right.
You know, people are afraid of heights or something, you feel a lot more secure in a closed area. So it just felt like the right thing to do, is to go bigger and make it larger, and to have it carry more weight.
Yeah,
Right.
we weren't really thinking about the business side of things actually, because I think before the Ron was like a motorbike guy, right? And then he
Right.
said like he wanted to build a flying bike, and that's how we came up with the Y6 configuration. Yeah, I mean that's how it really
To your
started.
guys'
Go ahead.
point, Zara and Derek, like that's exactly why I actually joined, because the two-seater at that point, like all the other companies were focusing on the air taxis, on the bigger models, or the one-seater. But when I saw the two-seater, it was a real game changer. And that was brought me in here. And I believe it's such more practical use case for personal solution, for personal use, especially compared to the air taxis. Zara, can you dive in a little bit onto the software side and how your team collaborated with Derek to make it fly? Because I know there's a lot of work you guys had to do. Derek was building electronic components, you were doing the software. Can you just give us a little like how you guys collaborated and got it to fly?
Yeah, in the early stages, definitely there was a lot of late night talks over Zoom. Yeah, we basically just dived into doing the requirements, and then we were doing wiring diagrams using whatever tool we had. I think it was Visio at the time. Yeah, I think it was like a long 2 weeks. I think it was just going through design iterations. I mean, we were using ready off the shelf products by then at the time, but I had to create like interface between the joysticks, the land sequence, or things like that. Yeah, I don't know what else is there. Yeah, it was.
So, I mean,
Yeah, go ahead.
we got the H1X to fly, we got the FAA certification on that. So can you
Mhm.
share a little bit like what was the key challenges of getting as you guys can see on the screen, the bigger model here that has experimental. This was the H1 prototype that we flew. So can you share a little bit about the challenges, what we faced, what we had to come over, because this is not something that anybody has done. We're the first in the US to have a two-seater that actually took off. So can you share about the challenges and how you were able to get through them and actually get it to take off the ground and fly?
You're talking about the this H1 are we talking about now?
Yeah, I'm talking about
Yeah,
the H1 because that was when we started raising money. We started to build the H1 model. I don't know how many of you investors remember when we did the first test flight. So if you could share like what went into make this fly.
Derek, do you want to start this or should I?
Yeah, I can start it. It's fine. There's lots of challenges with you're dealing with something that hasn't been created before, and you got like a blank slate. I mean, I spent many hours building the frame on that carbon fiber frame with Bob at the old place, and that was really challenging. I mean, we were trying to get it perfect. It has to be. I had to build fixtures to make it perfect on that. That's just the mechanical side of it. The electronic side of it was even more challenging. We had to bring it up to basically an FAA certification level to a certain degree. We didn't have to get all the way there, but we had to get it close enough that it would pass. We had to redesign. I had to redesign the landing gear quite a few times and build a custom final version. It just trial and error kind of thing on some of it. We were testing a lot of different devices. Czar was programming, having to program the flight computer, and that was very challenging because nobody had ever flown anything this large before on that type of a flight computer. So the reaction time and the way that it handles and everything is going to be difficult to understand. And as people who've flown drones know and built drones, it's challenging. Your first flight is always challenging. That's why we built this type of a contraption you can see in the picture to help us with the stabilization of the vehicle during flight tests. So that I put together very quickly with some different people as far as that goes. And yeah, that's, it's just, there's lots of common challenges. It's normal challenges that you experience in any type of a new build. They're always like that.
Right. So, Zar, remember what was like an crazy story that you can share, like when we were lifting off and trying to get us off of the ground? Do you remember any like interesting stories that happened? I mean, I remember like we had can you share a little bit of the story about when we started to take off and the propellers?
Yeah,
Yeah.
I could tell you that story. I remember it very vividly. um, it was a time when we had a demo for the Air Force, and the thing hasn't flown yet. It was a Monday. We were supposed to demo it on a Monday, and it's Thursday evening. This thing hasn't flown. So we've got all the propellers are engaged. We had everything ready, but we haven't proven that it's like flyable. So we had it on what was it? A harness? What was it? What do you call that thing again, Derek? Where you suspend it into a
Yeah, it's just a lifting harness
yeah, it was on a
fixture.
harness.
Call it. You can
And then
call it what.
yeah, it was a yeah. So it was mainly just in case it might fly away. So we put it on a harness. So I was piloting at the time. And then it got to a point like, we just push the throttle and then it lifted, but it the harness sort of pulled it back and the propeller hit the ground. Luckily, it didn't break off, but yeah, basically both the propellers at the back, as you can see there, they actually broke off, and we didn't have any spares. So, well, we had one spare in the office, but the other spare we found, it was actually in one of our suppliers, which is overseas. So we were like super frantic, trying to call all my friends all over the world to say, like, look, I need to send you on a mission. I need you to go to this place, go to that country, and then come back to Miami. Um, yeah, at the end, the supplier sent us one of his guys. He came Saturday evening. Damn, and I was like, no one, like, I think none of us did it. None of us slept during those few days. But yeah, I mean, the guy came. We tuned it. We put all the configurations, and then by Sunday, I think it was afternoon, it flew the first time, and then it flew. I think we flew it outside. I remember, and then it was just like clutch moment for Monday. That was insane.
Yeah, I
But yeah,
remember that. It's like these are the type of stories, and everybody here you can imagine. This is just one of um, hundreds of stories that have happened. Building something, what we're doing, no one has ever done it. We're a small team, starting to fundraise, and there's been a lot of, as I said in the beginning, a lot of challenges. But the good thing about our team, we're really good at solving solutions, and we're ready. There's these moments when you add the line and things could go right or left, and our team was always able to shine, and I'm showcased that we're capable of doing this. So Ido, I want to ask you about, so we started doing all this testing, we had their own flying. What have you guys gathered from what valuable data were we be able to get to collect, so it allowed us to move on and develop and continue developing our go-to-market product?
Yeah, so first, I joined just when the story that Zar just told, just joined a couple of weeks before. So I was joined when we did the first flight test, and then we had a lot of challenges at the beginning of getting this autopilot calibrated so it can actually take off smoothly and be stabilized and work very nice. So that was one of the challenges that currently we like we faced back then, and the ability to gather all the information from the autopilot, from the way we took off inside and outside, outdoor, started to like, getting this more and more information, more and more analysis reports, so we can see how exactly we're flying when you're taking off, how much stabilized we are, what we should calibrate on each of these motors and ESCs, so we can make sure that we're flying, taking off and landing really stabilized. So that was the first information we gathered. So we started getting all the information from the autopilot and different components and sensors we installed. We have like a sophisticated system that contained a lot of sensors that send us all the information to a backend server that we actually able to save them, store them, and later on analyze them to create the reports, to create like behaviors and anomalies. Means we can find if something went wrong, why, when, and how we can like make sure we can reproduce that to like, solve this issue. If it's like was electrical issue, was software issue. So we gather all this information, and then we also understand that we need like another machine, another concept for the motor test fixture. That's actually, instead of getting all the flight tests in different scenarios of the motor and the propellers, we're going to use that fixed machine that we can run a lot of different scenarios with a lot of different configurations for the blades, for the motor, put in like in a different environments as well, and then perform an enormous amount of tests in different conditions without actually, taking off and changing the H1, P1 all the time. So that was giving us a lot of information for an analysis, for improving the software, the electronics, understanding the aerodynamics profile behind everything. So we took all the information for the H1, P1. We kind of like understood how we can improve this one for the H1X. And meanwhile, we used the motor test fixture to run a lot of different scenarios. We'll talk about it more later on, but we use that one to actually understand how the Doroni H1X will work in real lifetime conditions, like with all the different sensors. We can actually measure the lift and everything. We'll talk about it more later on, but yeah, that's pretty much for the transition between the H1, P1, and the H1X in terms of software and analysis.
Beautiful. So before we go into the H1X, to the new design, Charles, back in December, you remember we received the H1, the FAA Special Airworthiness Certification, which was a huge milestone for us, which really helped us accelerate. We were able to raise more money, and we got a lot of publicity out of that. Can you help the audience understand what the certification means for the long term and how significant in terms of overall certification process and our journey to get the H1X ready to market?
No, absolutely, Abe. Excuse me. No, that was a huge achievement for us. That gave us a lot more to work with. And basically, the airworthiness certificate, every aircraft in the world has an airworthiness certificate. What this says is that the FAA recognizes you as an aircraft, that they've checked it over, that you're safe to fly, and allows us to do more extensive testing, and says we can test fly the aircraft under certain conditions and things like that. But it huge milestone for us back then. We had somebody come out. He looked over the wiring, he looked over the airframe, he looked over all our systems that we had installed. He asked us a few questions about this and that, and we got the approval. It was like I said, it meant a lot to us and to the investors. That it was a big jump forward, safety wise, visibility wise, all sorts of things.
All right, and that's definitely, we're working hand in hand with the FAA. And of course, like, this is still a new product, so we're actually working with the FAA to make the rules for this new industry coming up. So now, as we go into the H1X, as all of our investors and everybody that has been following us, that in March we have released our new design, our improved design, go-to-market design that we're going to start building in the next couple of months. Alistair, you joined the team after we started the test flights, and you immediately began working with the design team to redefine all the aerodynamics from the H1 design that we previously had, right? You really helped take the H1 from the concept to a go-to-market design that maximizes flight efficiency. Can you walk us through the thought behind the H1X design and why it's so innovative and groundbreaking.
Yeah, so let's think about what we had a year ago. So we had a flying model, the H1, which was great. That showed that Derek and Zar, they'd got the sort of vertical takeoff and landing aspect of an eVTOL working. But the design was close to evolving towards a standard generic quadcopter type design, which would have worked fine. But it might not have been able to capture the imagination quite as much as the H1X does, and look so attractive for you guys to buy and invest. So one of the main drivers was comfort for the passenger. So if you imagine a normal, typical drone quadcopter, in order to fly forwards, you have to tilt forwards quite dramatically in order to fly forwards at speed. And the faster you want to go, the more you've got to tilt forwards. And if you imagine flying for half an hour, tilting forward the entire time, that's going to be quite uncomfortable. And also from an efficiency perspective, if you're using all your motors, a bit like a helicopter, your motor is mostly there keeping you up in the air, not pushing you forwards. So the main concept was to try and make it fly more like an aircraft, so using the wings to create the lift so that you could not waste so much energy just keeping the aircraft in the air. An alternative way around that is to use tilt rotors. So for example, if you think Joby or Archer, some of those eVTOL aircraft, but that adds quite a lot of complexity into those designs in order to make things tilt in all the control aspects and design aspects. And that's why those aircraft that I mentioned, for example, they're being sold for millions. They're so expensive and costly to make that they can only really be suitable for a commercial air taxi type solution. Whereas part of the appeal of Doroni, and the main reason why I was interested in working with Doroni, is that the aircraft is one of, well, I can't think of any others really that are targeted for personal use, and they're priced at a range that you or I could realistically fly and use these as part of our daily lives. So part of the main Doroni philosophy is keeping things simple, because that keeps the weight down and also keeps the price down and keeps the complexity down. So that's why we've chosen not to have tilt rotors, not because it's impossible, especially because with Doroni we're trying to use the efficiency of having rotors in ducts. So within ducts, it makes the propellers more efficient. It makes them slightly quieter. It makes them certainly a lot more safer for, especially when it's landing on the ground. And if you try and combine tilting rotors with ducts as well, it's not impossible, but even more tricky and complicated. So what we're doing instead is it's another reason why the aircraft, for example, doesn't use ailerons or rudders or elevators for the control. We're using the lift rotors themselves, so they already have to be there for the lift. We don't have to add anything else in for the control. So yes, it might make Zar's software a bit more complicated, but from my perspective, complicated software and easy software weighs the same. So it's just as good from that perspective. So if tilt rotors are ruled out, then the main target was to make this fly more like an aeroplane in forward flight. So we've designed it, and it's an iterative process doing a lot of advanced CFD to try and create a lot more lifting surfaces. So that's why the aircraft is involved to have, for example, the lifting strut. So the rear landing gear is basically two big wings giving us a lot more lift. The main wings themselves, you can see there's more of a duct area and a wing surface area, and there's a patent pending wing fence between the two, which has been designed with CFD to help keep the air flowing smoothly over the wings, so that we get a lot more lift to drag ratio, so that the efficiency of the aircraft improves. Yeah. So
to your point, Alistair, if I can bump in, like the fact, I mean, I remember when we designed, we went through all the iterations, we closed our investment round, and like, okay, we need to, after we started test flying, there was months, I remember that went through of going through, I think we went over 10, 12, 15 iterations of different designs. And I remember where the one was constantly, no, it has to, there was a couple things that has to look really good. It has to feel very, very safe. for the passengers, and it just needs to work like a perfect, like Doroni likes to say, like a Swiss knife. And when we got to this design, it shows the simplicity. Simplicity is genius, usually. It's like to make a product so simple and so easy to use, it really shows that people don't really sometimes don't see the complications that went in and behind the scenes to make this happen. Because, just like any other product in the market that we know, the simpler they are, the more complicated, as you said, in software and everything. But it's just, this is a marvel. Like anybody that have seen it, there's nothing like this on the market. So, yeah. So kudos to you and kudos to the whole team for making this happen. So let me ask Derek. So now over the past 6 months, past 8 months, we've been working since we released it. We're working with suppliers, requirements, because this is going to be the go-to-market design that we know that this will be able to fit our mission. It will only get between 60 to 100 miles. At delivery. So Derek, can you give us a little bit over the past 8 months? Like you've done a tremendous amount of testing on the components, and you guys build the test fixture. Can you share a little bit, like all these testing on the components, what you've been able to learn, and what are you seeing down the road of how the technology is evolving, and how bigger corporations and suppliers are working together with us to make the H1X possible?
So been working on the test fixture many iterations. You saw one in the video where it was vertical. The new one is horizontal. I don't know if there's a picture of it, the slide, but anyway, we've got two different levels on the test fixture now. So it simulates the actual duct props. We can space those at any type of height that we want to create the aerodynamics of the vehicle, even from the ground effect. We can also test that. We're going to be installing a duct system inside of around that as well to test the duct's aero flow characteristics through the duct. It's loaded with sensors, so therefore we gain reams and reams of data that we can analyze later, as well as store for FAA evaluation. But what it's mostly for is to understand the physics behind each, the props, the motors, the ESC, and the battery combination in real life physics. So what we're trying to do is simulate the actual, without taking off, we're simulating the actual flight on the computer system. So Ito and Zarb and their team have been working on the software side of that as well. But we've gained much knowledge from that as far as what works, what doesn't work, what the limits are of each device, where we need to improve. That leads us to getting the right people to design the right motors for us, the right props for us. So everything we're doing is getting custom designed down the road. We're going to get those made. We're getting contracts with different companies right now, but that's our goal, is to make basically a aircraft that's easy to fly, easy to operate, no maintenance, as much as possible, so that you don't have to constantly be taking it in for repair or anything like that. Plus, simple to fly. I think Ito Czar can go over software side and so forth.
Sure. Yeah, so the idea behind the test fixture is to simulate on real life, real physics, how does the H1X will fly in terms of lift versus propeller distance, lift versus propeller inches, like the diameter, and a lot of different aspects that can be also taken into consideration, like what is the temperature outside, how far we're putting that from the ground. So once we're actually testing everything out, we can tell how efficient the propulsion system is. So instead of building a lot of iterations of the H1X itself, we're able to simulate all those in the motor test fixture. That's the idea. We have, beside other software simulations that we're doing, like the VR that we have, or the X-Men simulation, we have also this one, which is like physics, real life testing. So the idea behind it is to actually install the real props, motor and motor controllers on a rig in a X configuration one, as you can see here, coaxial configuration one above each other, and then run it through different iterations. Means we applying different RPMs to each one of those motors, so we can measure how many lift we managed to actually take off with. So we can measure how much thrust we gained for each one of this iteration, and also combining that with the RPM being applied, we're able to measure what is the behavior, the aerodynamic profile of this specific configuration. So we can say like a couple of inches from each other and a couple of inches from the ground. We're able to simulate all different real-life scenarios of taking off. Beside that, we have also different sensors that being installed to actually enforce and make sure that everything is playing right. So we have the RPM sensor, which is like another type of measurement that we can actually enforce and make sure that the RPM that we send to the motor is actually the RPM that we're really spinning at. So we kind of always validating ourselves, always testing that what we are doing is actually making sense and really happening. Beside that, we have the different laser sensors that actually measuring the temperature. So beside getting the internal temperature, we're also checking the temperature from the outside using laser, using different technologies that can help us to make sure we're not getting into heating issue and not getting things that can be have a problem later on with. Also, we have different shunts, current and voltage sensors that we're making sure that the amount of current we drain from the battery is not too much in different scenarios that we're spinning the RPM high, for example. And in total, we're measuring the lift and have a lot of graphs and a lot of data plots that we actually exporting from this. So we're combining each test with this video, so we can actually later analysis that. Beside the real, on-board analysis that we're doing, the operators of the motor test fixture, we have the post analysis that we're sitting on and watching the video, sending that to different experts, maybe even our suppliers, and kind of seeing what was the behavior behind it, what was the profile, the aerodynamic profile, or the the voltage current amount that you used. So we actually can take all the information and understand the big picture. The big picture is to create the H1X in the best and most optimal way possible. We're drawing minimum amount of battery, so we have a longer range, and applying a better aerodynamic profile for those props, so we have nicer, much smoother and fast, also more distance flights, and combining also this together. That's how we're using this to improve and develop the H1X.
Beautiful. So now let's dive in to some of the questions that people have. Let's go through here. First of all, guys, the work again, how much you guys have been able to accomplish in the short period of time with so much limited resources. But we are really able to get where we are now, and we are 5 days away of closing our campaign, where you guys have been super supportive of us and help us get this far. Let's shift a little bit into the questions. First of all, I want to clarify. Some guys are asking about the Saudi deal. Yes, as I was saying, it's early stage. We're really deep in with them. We have a MOU, a non-binding, very close. It's a disclaimer. We're not guaranteeing anything, but we strongly believe that we will receive the funding needed, because there's some other things that we're working on that we strongly believe that what we have is really strong, and we have the right partners that want to support us. And definitely you guys, by supporting us on StartEngine, allowed us to get to this place where we're now. So we're able to show, as you can see, the H1X, we have now planned out already to go into full scale production over the next months. So question over here. So So someone was asking over here, as battery technology evolves, do you think we'll be able to have a 4-person seat, Derek? Maybe you could talk a little bit about, what the difference between a 2-seater and a 4-seater, so people, because a lot of times we get the questions of people want to know, like,
4-seater, this is a question that's brought up quite a bit. We've been asked by major companies to build a 4-seater as well. I won't go into who they are. But the thing is with the 4-seater, that changes your entire FAA type certification you're going to have to get. You're going to have to go through a whole new. We're on the fastest path to production right now, is what we're on with the 2-seater. So when you go through for a 4-seater, you're going to have to go up to a different level, which means it's going to take many years to get to fruition. So it's not really a battery problem per se, to be honest with you. We can build a 4-seater. It's just a much larger battery. Just like the eVTOLs for air taxi, they just use a very, very large battery system. So it'll have to be proportional. So that's the reason we're not doing it right now, is because regulations and cost prohibitive.
Yeah, that makes a lot of sense. A lot of people don't realize the difference between our aircraft and a car, especially something that we're trying to build that's compacted. It's not just you could just put as much weight as you want. To lift off, to take off double the amount of weight, it's going to be usually double the size. So this is why our company is more focused on the personal side, not so the 2-seater is, as of now, the fits the profile best because it's compacted enough, it's light, it's a faster certification process. So yeah, let's go into another question that we got. What about the autopilot? How would that work? Zar, can you explain a little bit how the autopilot will work?
In terms of controlling the aircraft, I mean, it's it's fitting with this new concept that we have. What do you call it? Simplified flight controls. So I mean, I guess, how do I compare it to a standard drone? I mean, I guess it's fairly similar to, your everyday, in terms of how it works, but of course, it's a little bit more redundant than your normal drone. But of course, you have your autopilot, which is super redundant. We're gunning for a 4x redundancy, and all the autopilots will be developed against a what was it again? Against the 0178C and the 254 standard, making sure that they're really super reliable. Yeah, so I guess the from the autopilot's perspective, it connects with all the actuators, i.e. the 10 engines, connects with the joystick mainly, and all the other, maybe perhaps peripherals, buttons. But yeah, I mean, we will go through a functional hazard, a more detailed functional hazard requirements, functional hazard assessment, I think it was FHA, to figure out how the how our system will look like. Because of course, as redundant as we might want it, we don't need it to be super redundant. Otherwise, we're not going to get anything done. But yeah, I mean, I don't know if that answers the question.
Hopefully. I mean the autopilot, there's a few yeah, the autopilot, we'll have to, right, if I'm correct, the way we'll be able to fly, we'll have 2 modalities. You'll be able to manual, and then be able to have a autopilot as well, right? So be able to fly. Sorry for the balloons. It will be able to fly autonomously as well, correct?
Yeah, it's we were going through some first iteration in terms of, like, what type of flight modes are you going to have, how much assisted you're going to be, what is it going to be how is it going to look like in a GPS denied environment. things like that. Is it going to have ADS-B or global sense, local sense? Yeah, it's that's on the pipeline. Yeah, it's all very exciting.
Okay, beautiful. So let's try to get to these questions as fast as we can. So, Charles, pilot license. Can you give us a quick rundown on the pilot requirements and how that's looking? Are we going to need a pilot license?
There'll be some training involved. So realistically, we are a light sport aircraft, LSA. To fly an LSA aircraft, you need to be a minimum of a sport pilot. Sport pilot is about 15 hours of training with a small test at the end with the FAA to give you your license. Because these are such a different designed aircraft, the FAA is experimenting with adding some more requirements or changing some things around, so we don't have a full answer on that quite yet, but it's not going to be anything difficult. Trying to think of anything I can add to that.
Because there's still some in the works, right? If I remember, we still work with FAA exactly what type of licensing, but we're definitely going to need a pilot license. It's not just going to be anybody that's going to be able to just buy one and fly around without knowing anything. This is going to be
No, and nobody wants that either. We want to make
Right.
sure that everybody's trained and safe and knows how to operate the aircraft, not to mention knows how to stay safe in the airspace and keep away from everybody else, and everyone stays away from them.
All right. So Derek, a question for you about batteries and charging. We'll be able to charge. Someone asked about on a Tesla charger, and how we'll be able to charge this at home.
So you can charge at home, of course, at different speeds, depending on how much you want to invest in that. If you're just doing off the standard 240 outlet, like a dryer outlet, you only have 50 amps available, unfortunately. So you have basically 12,000 watts, 12 kilowatt available for charging. That's kind of slow. But the superchargers, we can use the superchargers at different locations. We're working on getting a proprietary, not really proprietary. We're trying to work with the manufacturers of the charging systems to see if we can get the DC to DC and the high power charging collaboration with them to build something for us. So that, I guess it is a little proprietary. So we want to get up much higher. We want to double that at least to 25 kilowatts, but we can go up to 250 kilowatt charging if you're using a supercharger. So what we want to do is make it as universal as possible. Unfortunately, with all these standards that people came out with, there is no standard. You've got Tesla plugs, you've got CSS, and CHAdeMO, and all the other connectors. We'll probably have to have a kit that goes in the aircraft that makes it interchangeable. So it'd make it easy for everybody. Whatever you like, you can just charge.
I know that makes a lot of sense. And yeah, that's what we're designing. So everybody thinking this will be able to be charged at Tesla chargers at your home. And Derek is making sure that he's user-friendly first, right? Making sure it's easy to integrate with the swappable batteries and so on. Let's see what else, what other questions people have over here. Yeah, the company's we're based in Florida. Is your autopilot proprietary? Can your autopilot take off and land now? Zara, I believe that, yes, our autopilot can take off and land now, right?
Yeah, of course. We've
Yeah.
proven that with the H1. So with the new design, we've got a pipeline where we have what was it? we're going to do some simulation of the new shape. So in our pipeline, of course, we also have, what was it again? A term called Iron Bird. So yeah, just to make sure that all the oh, actually, this is the effort that we're going to do to integrate all the other systems, like cabin system, lights, doors,
All right.
Yeah, I mean, can you elaborate on the question? I mean, yeah, I mean, we've proven that the autopilot works.
This was just a simple question. So, Alistair, quick, if we can elaborate for a minute or two about the safety features, about if the propellers fail, or if, system outage, can we glide? What's this backup safety systems that we have in place to make sure that our passengers will be safe in any scenario?
Okay, so the ultimate fallback, if everything does go wrong, there's an emergency ballistic parachute, which you'll be able to land the aircraft safely.
So meaning,
But that's
when would the ballistic parachute come into play? Like if what happens? So just people are
so the aircraft can survive with two of the 8 lift motors not functioning. It will still be able to fly as long as those 2 aren't within the same corner of the aircraft. You'll still be able to land safely. And if you did have a motor out, we would recommend you try and come down as quickly as possible, as safely as possible. But modern motors nowadays also don't just have one coil inside them. They might be made up of 2 or more coils. So the chance of an entire motor failing is less likely. You're more likely to sort of lose one of the coils, and the motor will still be able to run maybe with 50% thrust rather than full thrust. So so even then, it's less likely to need the ultimate backup solution of the ballistic parachute. In which case, yeah, you would pull a cord and the parachute would take care of itself, and it will be designed that the aircraft with the parachute would land still on its wheels, preserving as much of the aircraft integrity as possible.
Beautiful, beautiful. Okay, so I guess we're coming up on time here. So I definitely see there's a lot of other questions. We will get back to everyone. And again, I posted a link to my calendar, where you can book a one-on-one call with me and ask your questions, and we can walk through the investment process. So now we are 5 days away of closing a StartEngine. We raised $7 million. And as you could have heard, I hope you were able to get some insights here from engineers and the way we think about developing the product. And as we go into the next steps of development to actually build and showcase test flights of the H1X over the next year or so, there's a lot of work ahead, a lot of work, but we have a great team, and we know we have the best engineers in the world to get this done. If anybody would do this, if anybody can do this, it's us. And I can say that very strongly, and I believe this with all my heart, because building something like this, it's not just about your knowledge, it's about being able to perform and tackle challenges as they come up, and our team has been nothing more than that. So we're really excited for the future. We're really excited to share more announcements, show more progress and development over the next couple of months, and it will be a fun 2 years, just as it was the past 2.5 years. The next 2.5 years would bring us to exponential growth. And I've seen a lot of people asking about the shares and about, we don't know, we can't predict exactly what the share price will be in 2-3 years from now, but what we know is that we're building a revolutionary product that will change the way of transportation for the next 100 years to come. So we believe very strongly, and we know as we grow, the company will grow. And just look at the stock market, what the eVTOL industry is already doing, and what electric industry is. So just imagine when we start flying and people start seeing those in the air, what will happen. So we're very passionate. We're doing this because we strongly believe in our mission of making transportation faster, more sustainable, and making the world a funner and better place. So let's go over a little bit of the investment perks. You could go on StartEngine now. I will send out a follow-up email with all the information, including my link. So for tier one, we have $5,000 investors, get 5% bonus shares. And remember, if you're a previous investor, you will receive 100% bonus shares if you reinvest in this round. So it's really important. Look up, make sure that you're eligible for that, and because this opportunity won't last. This is the last time we will be offering this as we go into the next step. If you invest over $10,000, this is a big one. We got, I think, close to 30 or 40 of you guys that have invested over $10,000 that you received a free pre-order. Once this campaign is closed, you're all going to get your confirmations. You got 15% bonus shares, and you get the opportunity to come to our facility here in Pompano Beach and actually fly our simulator and see the progress we're making here. And you will be invited to our test flights. So if you're considering investing, consider this tier and be a VIP investor with us, and you will enjoy the benefits of that. It will be a lot of fun. So of course, if you invest over 25,000, you get more bonus shares, and of course, you'll get the free pre-order and so on. 50,000, you get 25% bonus shares, and over 100,000, you get 30% bonus shares. If you're an investor and you believe in the future of technology, there's no better company to invest right now. I'm sorry, this is how it is. We are changing, and we are bringing in a new way of transportation that will change the way of life. It will improve the way we do business, the way we interact with our family. It will just change everything. Just think what the cars did from the horse and buggies. This will do the same over the next 100 years. I know a lot of people have questions about how, what, when, where, but our team, we're doing it. And every day we come to work and how we're getting it done and moving closer. As we get to market, the industry will adapt to us, just like any new technology. It doesn't start, with 10 million and everybody will have it in the first couple of years, but it's steps, and we are the forefront in the US in doing it. So thank you so much for joining today. Again, book a call with me, and we will send a follow-up email with all this information. And thank you so much for your support, and thank you all the engineers for everything. So thank you, everyone. Have a good one, and we'll be in touch.
Uh-oh.